So the work we were doing yesterday, finding values of trigonometric ratios, we're not finding angles, we're finding values of trigonometric ratios, is the same as the work you did last year in Math 20. It's exactly the same with one exception, that now all of a sudden you have 3 additional trigonometric ratios. So last year we did problems in Math 20 where you had to find the sine of a rotation angle by finding the y coordinate and dividing by r, or the cosine of a rotation angle by finding the x coordinate and dividing by r, or the tangent of a rotation angle by taking the y coordinate of the point on the arm divided by the x coordinate. So what was different was we have now 3 other trigonometric ratios. Cosecant of theta, which is defined as the reciprocal. Well, I'll show this to you first. Cosecant of theta, which is defined as the reciprocal of sine of theta. So if cosecant is the reciprocal of sine of theta, and sine of theta is y over r, then cosecant would be the reciprocal of y over r over y. Secant of theta is the reciprocal of cosine. I don't know the origin of these words, where they came from. They're kind of goofy sounding, but secant of theta is the reciprocal of cosine of theta, which means secant of theta is r over x, because cosine was x over r. So we reciprocate, flip over x over r to get secant. And tangent and cotangent are reciprocals. So tangent of theta we know is y over x from last year. Nothing changed between last year and this year. Tan of theta is still y over x. What's changed is we've added something. Cotan of theta is x over y. The relationship, of course, between x, y, and r is that they're Pythagoreanly related. I think I just made up a new word. They are related by the Pythagorean Theorem, namely x squared plus y squared equals r squared. So, morning. Does anybody have any questions you would like me to go over? Go ahead, Jason. 5, okay. Which I believe, if my memory is correct, this is a classic kind of multiple choice question on an exam. What does it mean to say that 3 pi over 2 is less than theta, which is less than 2 pi? Well, I'm going to draw this out for everybody on a number line, then we'll translate it to the coordinate grid. But on a number line, what that means is that theta lies between those two numbers, and 3 pi over 2 is a smaller number than 2 pi. And in fact, that's something that you should know based on the structure of this statement. When we have less than or equal to, or in this case, less than, the smaller number comes first. So we might not recognize what this number is as a decimal, but it's definitely smaller than 2 pi. So what does that mean? When we translate this to a rotation, and I start rotating from 0, let's rotate to 3 pi over 2. 3 pi over 2 is to here. That's 3 pi over 2. On the other hand, 2 pi is here. So this area between 3 pi over 2 and 2 pi is from here to here. In other words, that's a very highfalutin way of saying the angle terminates, or the angle is located, or the terminal arm lies in quadrant 4. And the reason why that's going to be important is with that piece of information here, what you now know is that x is positive and y is negative. And that leads to all kinds of conclusions. I haven't even read the question yet. That leads to the conclusion that cosine of theta will be a positive thing because x is positive. and secant of theta will be a positive thing because secant is just the reciprocal of cosine. So if cosine's positive, secant's positive. On the other hand, I know looking at that statement if y is negative that both sine of theta, which is connected to y, and cosecant will be negative. I can also figure out, and I'll get to the question in a second, Jason, that tangent of theta and cotangent of theta will also be negative because in that quadrant, one of but not the other of x and y are negative and one's positive. Does that make sense? Okay. So that's useful because, you know, even knowing that little bit of information, you know that it's going to be C or D. It's a very useful piece of information. You've changed a multiple choice question to 4 choices down to 2 with a little bit of knowledge. Now, how are we going to find this? Well, we're asked for cotan of theta. Cotan of theta is defined. So all that stuff I wrote is just kind of probably for most people just going on in our heads. You're saying, oh, it's in that quadrant, x is positive, y is negative. Cotangent of the rotation angle is x over y. And that's, honestly, that is not something I've memorized. I really haven't. I always say it's the reciprocal of tan. Tan is y over x, so I flip it over to get cotan. Okay. I do memorize tan of theta is y over x. Now, cosine of theta, and again, I would describe this as a classic kind of question. You're given one trigonometric ratio, you're told about where the angle is in some way, and asked to find the other. Cos of theta is x over r, which means we can say that x is 4 and r is 5. I want to address something because I've had students in the past say, how do you know that x passes through a point, or the point has an x value of 4? Because the arm goes on forever, right? I don't. It's just a ratio. I could use x equals 2 and r equals 2.5. I could use half of these values. Or I could use x equals 8 and r equals 10. Because it's the ratio that's 4/5. If you divide 4 by 5 on your calculator, you're going to get 0.8, I think. If you divide 2 by 2.5, you're going to get 0.8. If you divide 40 by 50, you're going to get 0.8. So that's why we're allowed to do that. Anyway, now what we're going to do, Jason, is work on finding y. And the reason, our motivation for finding y is we already know x. We need to know what y is to find cotan. So we're going to use the Pythagorean theorem. There's one more little wrinkle in it that we actually don't really have to worry about. But 4 squared plus y squared equals 5 squared. You're going to square 5, subtract the square of 4, which will leave you with 9. You'll have 25 minus 16. And then you'll have y squared equals 9. So y equals plus or minus root 9, which is plus or minus 3. Of course, we've already figured out that it's going to be the negative, right? But if you didn't focus on that to begin with, I think this is a typing mistake. I think I meant to put 3/5 here. I don't know why. Yeah, I meant to put 3/5. To the rushed student, you might just go, oh, well, y is 3. So that means I'm going to have 4 over 3, but it's actually negative 3. So it's negative 4/3, which gives us D for an answer. Does that make sense? Yeah, I think actually this, I meant to have 4 on the top or something. I don't know. I'll look at that later. But that's okay, Jason. Okay. Any other questions? Go ahead, Ryan. 8? And you're going to have to repeat the letter for me, please.
B.
B, thank you. Why don't I have 8 up here? That's interesting. There it is. Okay, so we have a point that's on the terminal arm. It's in quadrant 4. So you've determined y already. And I believe for A, you've determined y to be -4/5. Am I right? Okay. And just for anybody else that's wondering, what Ryan and I both did to find out the y coordinate was we put 3/5 here. It's on the unit circle, so 1 squared, I don't care. And then you end up with 1 minus 9/25. You end up with 16/25. You take the square root. But you get plus or minus for y, and I know you're asking about b. But since it's in quadrant 4, which is the same conversation we just had with the other question we finished, we know y is negative. Now, b says, what is the value of tan of theta? Now, tangent of theta, tan of theta is y over x. So we now know y is -4/5 over x, which is 3/5. And I'm losing track between this class and my Math 20-1 class, okay? So if I had this conversation with you already, then you're just going to hear it again. I know that you're taught when you divide one fraction by another, and the fact that this line is the main division between those two numbers is important. If all three of those horizontal lines were the same length, I wouldn't know what it means. I know that you're taught in a lot of courses that you take one fraction divided by another, you accomplish the result by multiplying by the reciprocal. And that is a very useful tool. But that is a tool that is limited to complex fractions that look like this, a nice fraction over a nice fraction. And in the next unit, when we look at more complicated rational expressions that involve sine and cosine and that other stuff, you can't just multiply by the reciprocal. So what I would tell you is, this is called a complex fraction, and we have to get rid of these pesky little denominators, mini denominators. That's our goal here, to simplify this. And I can accomplish that by multiplying the top and the bottom by 5. And look where I wrote the 5s. I wrote it so that I can see clearly these cancel and these cancel. And then I'm left with -4/3. So the answer to B is -4/3. Is that okay? Any other questions before we move on today? Like I said, you did this last year. This is trig from Math 20, except we have this other layer here of these three reciprocal trig ratios. Now we're going to move on. And the title for this lesson is kind of awkward. Let me explain it to you. The reason why it's 4.3 part 2 and 4.4 part 1 is the second part of 4.3 is the exact same as the first part of 4.4. The questions are kind of camouflaged a little bit differently, but ultimately they're the same thing. And what this lesson is about is solving trigonometric equations. In other words, I give you a trigonometric statement, and what you need to do is find theta. We're not finding what sine of theta is. We're not finding what cotangent of theta is. We want to find out what theta is that makes statements true. So we start off with a warm-up with a very basic idea, and this is also from 20-1. This should conjure up memories from 20-1. Consider the statement sine of theta equals 1/2. Show that 30 degrees is a rotation angle that makes that true. Well, you know what? I don't know what we want to write here. You could just take your calculator. Let's try this. Put your calculator in degree mode and take sine of 30 degrees. This is how we check to see if a suspicious or a suspected solution is really a solution. You get 0.5, don't you? Okay. I mean, ultimately, I think at this level, you should understand that sine of 30 is 0.5 because on the unit circle, 30 degrees has a y coordinate of 0.5. I mean, and I'm not even going to write anything down here. You could just say, well, you don't have to write anything down, but you could write, well, on my calculator it's true, or according to the unit circle it's true. Now what about 150 degrees? Can you please confirm on your calculator that 150 degrees is also a solution? So the sine of 150 degrees gives you 1/2. And you know, again, you should be able to understand that, because if you look on the unit circle and you just look up here at my arms, 150 degrees is 30 degrees shy of 180, which means that you look at the y coordinate and on the unit circle, it's 1/2. Why are these two solutions in quadrants 1 and 2? Like, here are the two terminal arms. There's 30 degrees and there's 150 degrees. Why is it that these happen to be in quadrants 1 and 2? What's significant about those two quadrants? Evan? Y is positive. And y, WHY, how come the statement y is positive is important in this question? I'm sorry? Right, because sine is y over r, and in the question it said sine of theta is 1/2. This is y over r, or if you like on the unit circle, it's just y. But the bottom line is sine is positive, so it's in quadrant 1 and 2 because that's the quadrants, those are the quadrants where sine of theta is positive. It's because sine of theta is greater than 0 in quadrant 1 and quadrant 2. If you were to come up with a different rotation angle that's coterminal with 30 degrees, like 390 degrees is coterminal with 30. Because if you go to 30 degrees and you just go around another 360, you'll end up at 390 degrees for a rotation. Do you have a question, JV? I'm sorry, I apologize. So, for example, 390 degrees is coterminal with 30 degrees. Can you confirm that sine of 390 degrees is still 0.5 on your calculator? How many of you were comfortable enough not putting it into your calculator and you know why it's going to be 0.5? Kind of. The answer is because it's in the same location. Remember, it's the location, not the trip. It's the location, the destination, that determines the value of a trigonometric ratio. Are you good now, Trevi? Okay. So, you know, I go back to say this diagram. Although this green arm is showing a rotation of 30 degrees, the green arm is also showing a rotation of 390 degrees. So any coterminal angle, by definition, will land on that green arm, and the y coordinate on the unit circle is still going to be 1/2. And the same can be said of this. So, yes, the reason for it is, as long as you land at that location, the ratio of y over r is going to be 1/2. Doesn't matter how you got there. Whether you went around 1,000,000 times and then stopped there, or you went backwards 120 times and then stopped at a particular place. Okay, so write the general statements that describe all angles. What I'm saying here is, if I told you that sine of theta was 1/2, how can you tell me what all solutions to that equation are? We could write theta equals 30 degrees, comma, 390 degrees, comma, negative 330 would be coterminal. Think about that for a second. Negative 330 would land at 30. But we can't write them all. So what we can do instead is we can say theta equals 30 degrees plus n times 360, where n is an element of the integer set. Do you remember when we wrote something similar for coterminal angles, and I made a big deal that technically this is wrong because you shouldn't include 0 for one of these values of n. Because if you use 0, then you're saying 30 degrees is coterminal with 30 degrees. We want 0 here, because 30 degrees is a solution to this equation. This is not saying what are coterminal with 30. This is saying what are solutions to that equation. So we have to include that. Could you write plus or minus n times 360 and say n is a whole number? Yes, because whole numbers include 0, 1, 2, 3, 4. That's only 1/2 of the solutions. The other solutions would be 150 degrees plus n times 360, where n is an element of the integers. Any questions with that entire warm-up? I feel as though the second warm-up is something I just want to remove from my lessons, because this is something that you should know. So I'm not going to spend a lot of time with this. The question is this. In quadrant 1, is sine of theta positive or negative? Is cos of theta positive or negative? Is tan of theta positive or negative? And I mean, I could explain it based on x, y, and r up here, but I could just say to you, look, in quadrant 1, x and y are both positive, and r is always positive. So any ratio of any two of those three things will give you a positive result. I'm going to approach it from a different standpoint. Let's talk about cosine of theta. Cosine of theta is related to x. It's x over r. So in these two quadrants that I'm pointing at here, 1 and 4, that's where x is positive. So cosine of theta is positive in those two quadrants. On the other hand, these two quadrants that I'm pointing at, 2 and 3, are where x is negative, which means that cosine is negative in these two quadrants. Where is sine positive? Well, sine is related to y, so sine is positive up top where y is positive. And sine is negative down below where y is negative. What I'm getting at is everybody in the classroom, you need to be able to determine very readily, very quickly, which two quadrants a trigonometric ratio is positive or negative in. Tangent, well, okay, tangent's a little trickier. Tangent is y over x. So if y and x are both positive, then tangent would be positive. If y and x are both negative, then tangent, which is y over x, would be positive. So tangent is positive in these two quadrants. Tangent is be negative in quadrant 4 and quadrant 2, because in those two quadrants, in each of those two quadrants, one of, but not the other, of x and y are positive and the other is negative. Cast. How many of you use the cast rule? Or add sugar to coffee. I like add sugar to coffee because then you start in quadrant 1. Cast is kind of not goofy, but weird because you don't start in quadrant 1, you start in quadrant 4. In reality, I don't like any of these rules. I just like knowing where x is positive and negative and where y is positive and negative. That's the way to go. I'm sorry, I can tell that some of you are wondering about this. These letters tell you what's positive. A means they're all positive. S means only sine is positive. T means only tangent is positive. C means only cosine is positive. I mean, it's a useful tool, but it's just a memorization thing. Okay. So now let's solve some equations. And this is all Math 20 in principle. This, everybody, is basically a Math 20 question. We're asked to find all of the solutions to this equation in the domain from 0 to 2 pi in decimal form. So if this said, you don't write this down. If this said cos theta equals 0.5240, and it was 0 degrees is less than or equal to theta, which is less than or equal to 360 degrees, that's a Math 20 question. And your first step would be to find a reference angle. It would be to use your calculator and go inverse cos of that number to find a reference angle. And if you did that, you would say, oh, the reference angle is 58 degrees. Are you with me on that? Then you would say, since cosine of theta was positive, I'm looking for a reference angle of 58 degrees in quadrant 1, where cosine is positive, and I'm looking for a reference angle of 58 degrees in quadrant 4, where cosine is positive. So if this were a Math 20 class, you would draw this. I know that's not remotely drawn to scale, but I don't care. And you would draw this. And I would make a really big deal in my Math 20 class that there's no arrow on the end of this arc. There's no direction to a reference angle. A reference angle is the angle between the arm and the x-axis, always. But then I would say, all right, theta is actually that, because it's between 0 and 360. So here you would have to take, this would be, well, theta would be 58 degrees. I don't think we need a PhD in mathematics to see that that's 58 degrees, right? Here, this requires a little more thought. Since 360 degrees takes us all the way around, this would be 360 minus 58, which last I checked is 302 degrees. Does this ring a bell? I hope it does. Okay, we're just going to do the same thing, but you got to put your calculator in radians, because we want decimal answers. So what is the reference angle? The reference angle will be the inverse cosine, and this is what we're writing down, of 0.5240, but we would like to be in radian mode. Well, we wouldn't like to be, we want to be. Whether you like it or not, we're going to do this. So we go inverse cos of 0.5240. And here's the problem. This is what can all of a sudden become confusing. When you got, if you did this in Math 20, you got 58 degrees, your mind can picture that, right? 58 degrees. You see this number and you might even say, geez, did I make a mistake? Well, no, because you're in radian mode. By the way, remember 1 radian is about 60 degrees. Okay. So what you would do here is you would say the reference angle is 1.0 radians. We're just going to round it to 1.0 because it says to the nearest tenth. And this will be in quadrant 1 and quadrant 4. Why is it in quadrant 1 and quadrant 4? Because cosine is positive, and those are the 2 quadrants in which cosine is positive, because that's where x is positive. I think it's a good idea to draw these separately. There's nothing wrong with putting both rotation angles on the same grid, but I think it's clearer to somebody looking at your work that you understand what's going on, rather than crowding it all on one. So we draw 1.0 rads. We draw 1.0 rads. We don't need to write the symbol rad. You can if you like. And I might even recommend that on a written response, but you don't have to, because if there's no symbol, by default it's rads. The question now is, what is theta? And what is theta? Well, theta in quadrant 1 would just be that reference angle. So I really want to stress something here. Theta, what I'm writing in green, is not the same as theta reference. Well, they happen to be equal to each other in this case, but they don't mean necessarily the same thing. Over here, look, if in Math 20, we would find this rotation angle by taking 360 and subtracting the reference angle, then here we're going to take 2 pi and subtract the reference angle. So you're going to take 2 pi minus 1.0, and you're going to get 5.3, rounded to the nearest tenth. Am I right? And I literally mean, pi is a number. It's not some kind of variable. You're going to go 2 times pi minus the 1.0. And do you, in fact, get 5.3? You'll get 5.28 something, but we're rounding to the nearest tenth. So you get 5.3. So those are the two solutions. Any questions with that first example? Kind of a 3-layer process. Find a reference angle. Find the quadrants where that reference angle needs to be drawn. The order in which you do those two things doesn't matter. Then find the rotation angle for each of those drawn situations. So if I say to you cosecant equals this from 0 to 360, we need to automatically put our calculator into degrees. Yep. Yours is different? Okay. Can you repeat that, please, Jason, what the number is? Oh, it's 1.6588. Must just be a typing mistake on my part. Yes? Okay. Well, of course. So it would be really nice, and you can write this down or not. I don't think it's very valuable, for you to say that the reference angle is the inverse cosecant of 1.6588. So a couple of things here, first of all. When you find a reference angle by going inverse on your calculator, you never include a negative, okay? Ever. If you do, then you have to learn 3 different sets of rules depending on whether it's cosine or sine or tangent. However, my bigger point is this. It would be nice if we could do this, but you don't have a cosecant key on your calculator, do you? So what we have to do is say to ourselves, since cosecant is the reciprocal of sine, so I don't think this is valuable at all. I'm just writing down to make a point. Since cosecant of theta is the reciprocal of sine, then sine of theta is the reciprocal of cosecant. And we're going to use this piece of information to turn this from an equation that has cosecant to one that has sine. Now, be very careful about what this means. This means that sine of theta is equal to the reciprocal of cosecant, but cosecant is this number. So sine of theta has a value of -1 over 1.6588. You know me by now. I just like my negatives on the top. This is our first step in the problem. It's an added layer because you have to change it into something that your calculator has keys for. Okay, now we can find the reference angle by taking the inverse sine of the absolute value of that number. We don't go inverse sine of a negative, ever. And we're in degree mode, so this is maybe a more recognizable frontier that we're walking through here. Inverse sine of 1.6588. Am I in degree mode? Yes, no, I'm not. inverse sine of 1 over 1.6588 gives me a reference angle of 37.1 degrees. Which two quadrants will this terminal arm lie in? Quadrant 3 and 4. The lower level quadrants where sine is negative. When you look up at the question, even though we took the inverse sine of a positive number to find the reference angle, sine was negative because cosecant was negative. Sine and cosecant are both related to the y coordinate. R is positive, of course. I see I have a typing mistake up here, don't I? It should be y over r. Anyway, we're looking at, and if you're watching this on video, I'm pointing at a different screen with the typing mistake. This will be in quadrant 3 or quadrant 4. So this is 37.1 degrees. This is 37.1 degrees. I would go so far as to say that I shouldn't even need to explain how we're getting the two angles, but I will write them out. This rotation angle will be 180 plus 37.1. This rotation angle will be 360 minus 37.1. So my two solutions are 217.1 degrees and 322.9 degrees. Thank you, Jason. So those are the two rotation angles in that domain of theta from 0 to 360 degrees. Questions with B? Oh, well, look, this is no different. Well, no different, except, of course it's different. There's a couple of differences here. One is it's an exact value, and we want to be in radians. And the other is we just got a little bit of work to prep this equation so we can go, what's the reference angle? We have to subtract root 3. Now, I want you to listen very carefully to this part. We have tangent of theta equals negative root 3. We want an exact value in radians, right? We want an exact value in radians for a reference angle so we can work with it. It will be the inverse tan of root 3. So humor me, put your calculator in radian mode and find the reference angle. I don't know what number you're looking at, but I can tell you this, it's not recognizable, is it? I'm going to say that you're looking at about 1.04 roughly radians. But I want to know an exact value, and that is a multiple of pi. So it's not easy to figure that out, so here's what we do. We cheat. We put our calculator in degree mode. We put our calculator in degree mode and repeat the process. Because we will recognize angles in degrees before we recognize them in radians. And when you are in degree mode, and you take the inverse tan of root 3, you get 60 degrees, right? I think, yeah. Oh, so what is the reference angle? Pi over 3. So on a written response, you write this. You have to write this, and you have to write this. Nobody cares how you figure out what the inverse tan of root 3 is, so don't tell anybody. Okay, so it's pi over 3. Now, in which two quadrants should I draw this reference angle? Well, tangent's negative, so quadrant 2 and 4. And I'm really, everybody, I'm saying you need to be able to identify those quadrants very quickly. If tan is negative, either x is negative and y is positive, in which case it's quadrant 2, or y is negative and x is positive, in which case it's quadrant 4. So all we're going to do here is we're going to sketch this reference angle of pi over 3 here, and we're going to sketch it a reference angle of pi over 3 here, and you're going to figure out what this is and what this is. And I don't know where you're at with all of these angles in this circle yet. How many of you can see immediately that this is 2 pi over 3? Couple. 1 pi over 3, 2 pi over 3. This is 5 pi over 3. 1, 2, 3, 4, 5 pi over 3. So those are our two solutions. Could you solve the whole thing in degree mode and then do a bunch of conversions? Sure. Any questions with C? Well, let's rearrange for D for sine of theta. 2 sine theta equals root 3. So sine of theta equals root 3 over 2. This is a math 30 teacher's dream. That you look at that and you go, oh, it's this location and this location. Because on the unit circle, that's where y is root 3 over 2. The solution is pi over 3 and 2 pi over 3. Except I think we want them in degrees. Did I see degrees there? So 60 degrees and 120 degrees. And that's really the beautiful thing about the unit circle is you can get rotation angles quite easily. These 2 points both have y coordinates of root 3 over 2. This is 1/2 root 3 over 2. This is negative 1/2 comma root 3 over 2. It doesn't mean you have to do it that way. You could find a reference angle. Inverse sine of root 3 over 2. Do me a favor, find the reference angle by taking the inverse sine of root 3 over 2. In degrees because we want an exact value. Even if this said radians, we want it in degrees. You get 60, right? Okay, so then what you would do is say, all right, the reference angle is 60 degrees, and sine is positive, so I need to draw a reference angle of 60 degrees here, a reference angle of 60 degrees here. What's the rotation angle? 60 degrees, 120 degrees. Does D make sense to you? Does anybody have any questions with D? JV? Yep. Oh, I'm rearranging that equation for sine of theta. If I had 3x minus 5 equals 0, and I want to know what x is, I have to move this 5 over and then divide by 3. And that's what I did. It may seem unfamiliar to you because we're not just subtracting a whole number, we're subtracting a radical. Or we're adding, I guess. We're adding root 3 to both sides. So at this stage, what I've done here, to get to here is I've added root 3 to both sides. Does that answer your question? Okay. I didn't ignore the negative because we're supposed to ignore the negative. Okay. Any other questions with that one? This gets tricky now, okay? It's in radians, and we want it to the nearest tenth. And what's tricky about it is the stupid domain. Look at the domain. We want any numbers that are between negative 3 pi over 2 and 2 pi, or including them. So I think something that's helpful here, everybody. Help me out here. Does this class end at about 10:36? Yes? Am I going too fast? Okay. I think what's going to be very helpful for you here is to figure out what these numbers are in decimal form. These are the allowable values of theta. So I really want you to figure out what -3 times pi divided by 2 is equal to. I want to know what the number is so I can see it. Four point seven. So I'm just going to say -4.7. And if we need those other decimals at some point, we can, put them under a magnifying glass and look at them. And then we want to go up to 2 pi, which is 6.28, approximately. I guess we could write 6.3. Are you okay with those numbers? Okay. So anytime we record theta as an answer to this question, it has to be in this domain. So the first thing to do is what JV and I were just talking about in the previous question. We need to isolate the trigonometric ratio, in this case, tangent of theta. Now, we want answers in radians. And if it's said as an exact value, then we would put our calculator into degrees to recognize the numbers. But we don't want exact values. We want decimal values in radians. So these numbers we get are going to be unfamiliar to you in terms of an angle. But you have to put your calculator in radians. And we're going to find the reference angle. This will be the inverse tangent of the number 2. So the reference angle is inverse tan of 2, which gives me 1.1 radians. Okay. Now, as soon as we got to this example, things took a turn for the more complicated. Remember, this theta reference is not necessarily theta. Okay. Theta, which I'm going to put in red, these are the answers to the question. This is not an answer to the question. It's a way for us to locate 2 rotation angles in the first revolution. And that's what I would like you to do at this point. I would like you to actually think that it's this. Okay, ignore when you see a really weird domain, just ignore it for the time being. Solve the problem as if you're going from 0 to 2 pi. So tangent of theta was a positive number. In which 2 quadrants is tangent positive? Well, 1, where x and y are both positive, and 3, where x and y are both negative, because negative divided by negative gives you positive, and tangent is y over x. Okay. So we'll come back to reality in a second, but let's imagine that this is the reality. What we would have then is 1.1 rads here and 1.1 rads here. And the rotation angles, theta, would be what I am indicating in green. And we know how to answer this question. You would just say, well, this theta is 1.1, and this theta would be pi plus 1.1, because it's pi radians up to the negative x-axis, and then we have to add the 1.1. And as a decimal, I believe that's 4.2 rads, but perhaps you can help me out. Okay. So now what we are going to do is we are going to ask ourselves, we're going to start with this rotation angle of 1.1 on the left of the bottom of the screen. And it's theta, it's not a reference angle. Is 1.1 in between these numbers? Sure it is. It goes from negative 4.7 all the way up to positive 6.28. It's going to pass through 0. Right? 0 would be about here. And then it's going to get bigger and bigger. So 1.1 is in there, so we put it in our list of solutions. We're not done with 1.1. Because this location right here, this terminal arm that I'm going to indicate in red, is the place that tangent is equal to 2. But it's not the only way to get there. I could, instead of going 1.1 rads, I could go 1.1 plus pi rads, couldn't I? Sorry, I could go 1.1 plus 2 pi rads. So what I'm really doing here is I'm making a list of coterminal angles with that 1.1. So I'm taking 2 pi plus 1.1 and I figure that out. You figure that out. And you get 7.38, I think. Okay, so I'm going to write down 7.38. Well, is that in this domain? No. So we can cross it off the list. I hope it's clear, if you look up here, that if 7.38, which is over here, is not in the domain, adding another 2 pi is not going to lead us to something that's in the domain, right? Does that make sense? Because it'll be even more. But what about if we take 1.1 and we subtract 2 pi? That would give us another way to get to this red line. And you need to actually now take 1.1, subtract 2 times pi, and you are going to get negative 5.2 approximately. Am I correct on that? So you would get negative 5.2, and then there's your eyeball, you look up here and you say, is negative 5.2 in the domain? And you go, no. So that means it's not that you've wasted your time, it's that you've determined that it's not a solution. So now let's move on to the 4.2. Is 4.2 in this domain? Okay, so 4.2 is a solution. What about 4.2 plus 2 pi, which would take us to the same place? I realize some of you can visualize this and answer that question without calculating it, but not everybody can. When you add those two numbers together, you're going to get well over 10, aren't you? 10.4, I don't know. Well, that's not in the domain. What if you take 4.2 and subtract 2 pi? You are going to get a number that I believe will be very close to negative 2.1. To the nearest tenth, am I right? Negative 2.1? So we get negative 2.1 here. Is this in the domain? Yep. Let's subtract 2 pi again. Basically, you're taking that angle that we found on the left side of the screen, you're adding 2 pi until you break the barrier of the domain. You're subtracting 2 pi until you break the barrier of the domain. If we subtract 2 pi again, you're going to get negative 8 point something, which is outside of the domain. So these are the solutions. Okay. Let's try this one now. Negative 180 to 180. This will be a little quicker because it's degrees and it makes a little more sense. I am going to rewrite this as secant of theta equals negative 9, which means cosine of theta is negative 1/9. So I did two. Your number is different, obviously. There's a 5 in front of the secant. So you end up with secant of theta equals -9/5. So I'm subtracting 9 and then dividing by 5. That means cosine of theta is -5/9. What's the reference angle? So you're going to have to go inverse cos of 5/9. Not the negative, though. You don't include the negative. We want to be in degrees. Sorry? Oh, I'm sorry. I didn't hear you then. I thought you said 6.25. 56.25? I'm going to call it 56.3 degrees. Which two quadrants would this reference angle be in? Well, cosine is negative. And quite frankly, if you're getting a little bored with this, then that's good because you get it. We're looking at quadrant 2 and 3. So we would sketch 56 degrees here. I'm writing 56, but it's 56.3. You'd write 56 here. This is theta. This is theta. Do me a favor. Calculate those two values of theta by using your knowledge of the angles at the quadrant endpoints. (123.9 degrees). Yes. 236.1 degrees. 0.7. Oh, it's yeah. And it's 3 here, right? 7 and 3. Okay. I was thinking 1. Are we good for those rotation angles? Okay, I'm not going to draw a number line. Look up here. You should see a number line, -180 to 180. Is 123 in that domain? Be very careful. Think about the numbers. You're going from -180 up to +180. You're going to pass through 123. We're not thinking this way. You're not thinking rotations. Is it in the domain? You're just thinking a number line. 123 is in there. I'm just going to write, we'll write 123.7 degrees. If you add 360 to this, you will end up in the same place. Is it clear that when you add 360 to this, you will be outside of the domain? I mean, you can only go up to 180. What if you subtract 360 from it? If you subtract 123.7 minus 360, you're going to get around 200 and something degrees, aren't you? Negative? Well, that's outside of the domain because it's got to be between -180 and 180. So that is done with that. Is this in the domain? No. I hope it's clear you're not going to add 360 to it to find out if the next angle is in the domain. But what if you subtract 360 from it? If you subtract 360 from it, you get -123.7. Am I right? Is -123.7 in the domain? Then it's a solution. It's a lot more complicated than just looking at your calculator here. If you subtract 360 again, you will not be in the domain. We are adding and subtracting multiples of 360 because that's how we find coterminal angles. Now we have one last question to do, and it's really quite simple. So this question says, what is the general solution to example 1a? I will tell you right now that in 1a, we got these two numbers in radians. Those were our two solutions from 0 to 2 pi. In 1b, these were our two solutions, I believe. Can you just check to see if they match? I might have changed some questions. Do they match? Okay. So what do I mean by a general solution? Well, let's start off with b. This 217 degrees took us to a particular location that made the equation true. Please. To get a general solution, you have to add multiples of 360. That's it. Here you have to add multiples of 360. When I say add, I actually mean add or subtract, which means n is an integer. Okay? N is an integer for all of these. Here you would go 2 pi n. Because these are in radians, you want to add or subtract multiples of a full revolution. But a full revolution in radians is 2 pi. I really want to make sure that everybody understands. When I say for all of these n is an integer, that means you are either adding or subtracting multiples of 2 pi, or adding or subtracting multiples of 360. That's all you do for this. You take your answers that you got, and you say, well, I'm going to add or subtract multiples of 2 pi. Or multiple means a whole number value. So these are all plus 2 pi n. These are all plus 360n. And for all of these, n is an integer. So this is the lesson where everything kind of came together. It's the perfect storm of everything that we've learned. X, Y, R, 6 trigonometric ratios, quadrants, positive, negative, reference angles, rotation angles, different domains. It all came rushing at us. Tomorrow we are going to be looking at more, it's hard to believe, but more complicated trigonometric equations. So it's very important academically that you can solve these types of questions. You know, cos of theta equals a half. 5 minus 10 squared equals 4. That's a little bit different. We'll have to go over that tomorrow. But anyway, I think I've given you specific questions here that I would like you to do. And you still have about 15 minutes. Get settled in, and I will come around and give you a hand once I get attendance taken. Remember, if you need to leave, of course, that's okay.